Welcome one and all to the second part of the fractions review, where we are going to focus specifically on adding and subtracting fractions. If you haven't done so, check out the previous video where we focused on the LCD and the multiplying and dividing. Let's get started. This is where knowing those two constants from before is going to all come together in this video. What we need to do first is we need to get the denominators to be the same. In order to do that, we need to find the LCD. Now, I will not take the time to actually write the steps out for the LCD. I'm going to go ahead and just write it out. With this example, the LCD is going to be 15. So now what we do is we are going to convert each fraction so that they share the same denominator. That's our goal. So 5 over 3, we are going to multiply with the open-ended fraction. Plus 8 over 5, that is also going to be multiplied with an open-ended fraction. Question is, what are we multiplying each fraction with? Well, the first fraction, 5 over 3, we need to think about what can I do to get the denominator to be 15. So what can I multiply with 3 to get 15? In this situation, it's going to be 5. So for the second fraction, what can we multiply with 5 to get to 15? In this situation, it's going to be 3. And you have to do the same number for both top and bottom so that we don't break any rules to this problem. Multiply the first pair of fractions together. 5 times 5 is 25. Over 3 times 5, which is 15. Plus 8 times 3, which is 24. Over 15. I am very sorry about my chicken scratch on the floor. I'm going to fix that because it looks like a tiny trident. Let's see if I can get that proper. There we go. I'm going to scroll down too so we have space. Because there's only one more step to this, is now we are going to actually combine those two fractions together. We already know that the denominators are the same. That's what allows us to combine them together when we're adding and subtracting. So now we say, alright, add the two numbers on the top together. 25 plus 24 is 49. And that is the answer to this example. Let's go to the second example. We have 11 over 6 minus 3 over 8. Just because it's minus doesn't really change what we do here. So let's go ahead and identify what the LCD is. The LCD in this example is going to be 24. So now we say, alright, what do I multiply 11 over 6 with to get the denominator to be 24? Well, 6 times 4 is going to equal 24, and we do the top also with 4. Subtract 3 over 8. What do we multiply the second fraction with? Well, in this example, we're going to multiply both top and bottom by 3. 8 times 3 is 24. Multiply these together. So I just want to fix that 4 real quick. 4s are a problem in this video. Multiply the two pairs of fractions together. 11 times 4 is 44. We already know that the denominator is 24 because that's the whole goal of finding the LCD. Minus 3 times 3 is 9, and then over 24. Well, ladies and gentlemen, we got the denominator to be the same, so we can go ahead and combine that into one fraction. 24 is our denominator, and we say, what's 44 minus 9? Well, that's going to be 35. We check to see, is it reducible? Thankfully, no. So we go ahead and stop right here, and that's our answer to that example. Now, this third example is a little unique because of the fact that we don't have a fraction. We have a natural number minus a fraction. Well, this is actually going to be one of the easier problems because whenever you have a natural number, you want to convert it back to a fraction, you just set it over 1. And then as for the LCD itself, well, our least common denominator is going to be 4. Whatever fraction is there when you're adding and subtracting with a natural number, the denominator will always be the LCD. So now we take the first fraction, 4 over 1, and we say, what do I multiply with 1 to get to 4? Well, that's pretty straightforward. You just multiply by 4. And then as for the second fraction, well, the denominator is already 4. So you don't multiply with anything, so you only have to convert the first fraction. And that's going to give us 16 over 4 minus 5 over 4. Then you go ahead and just say, all right, what's 16 minus 5? That's going to be 11. we already knew that the denominator is going to be 4. So our final answer is 11 over 4, which is not reducible. So we stop there. Alright, last example. 1/2 plus negative 7 over 4. So this is plus a negative. And we'll get to how that's going to change a little bit for us when we get to that. First, establish the LCD. Well, this is also kind of nice. The LCD is 4 for this example as well, which means that we only need to convert one of the fractions, and it's going to be the first one. So 1/2 times 2 over 2, because 2 times 2 will give us 4 in the denominator. As for the rest of the problem, plus negative 7 over 4, thankfully we don't need to convert that, so we go ahead and just write this as 2 over 4 plus negative 7 over 4. Now, when you get to the part where the denominators are the same, what I'm going to do a little bit different is this. If your fraction itself is negative and you want to combine it with another fraction, you can move that negative to the top. Because a fraction can have a negative on the numerator, which is the same as having the negative in the denominator, which is the same as having the negative in front of the fraction itself. So we're just manipulating the problem in our favor. So now we can go ahead and get the final answer. When you're combining fractions together, or adding, subtracting, obviously the denominator is always going to be the same. Now we look at the top and say, all right, what's 2 plus negative 7? So if you have more negatives than positive, we already know our answer on the top is going to be negative. It's just what's the difference between the two? It's going to be 5. So our final answer to this problem is negative 5 over 4. Hope that is clear enough for you for a review. So go ahead and work on these examples on your own. Pause the video here, and when you are ready to check your answers and your work, resume the video. So pause here, and resume. So, sorry, that was a bit over-exaggerated. I'm going to scroll down here. Alright, here's the work for the first problem. The answer is 17 over 12. Didn't have to reduce that. Second example, you get that. It's 11 over 42. Didn't have to reduce that. This one we did have to get the LCD to be 20, so the final answer is negative 9 over 20, because when you add two negatives together, you're technically adding them together, and it just stays negative. And the last one, you had to convert the 1 over 3 over 3, 1 to 3 over 3. The final answer is 1 over 3. So adding and subtracting is definitely one of the more harder aspects of fractions. Hopefully this video covered any gaps and holes that you had originally, and please make sure you get this down, because when we actually enter the trig portion, it is going to be a very, very important aspect. There you go.